Welcome to another enchanting episode of Laugh and Code, the Elm Programming Show, where code and comedy meet under the spotlight. Today, we're entering the mystical realm of Elm to uncover the magic of functions. Picture this: each function in Elm is like a spell with the power to transform data in extraordinary ways. In this video, we'll cover function fundamentals, higher order functions, anonymous functions, and how in Elm, all functions are pure. So grab your coding wand and let's conjure some Elm magic together. If you've been playing along in our series, you're probably besties with the online editor by now. But guess what? There's another secret weapon in our Elm arsenal: package.elm-lang.org. This treasure trove is where all the Elm goodies, packages, live. Remember when in our Hello World example, we imported HTML? That's just the tip of the iceberg. In the online editor, hitting packages on the bottom left is like opening a portal to packages land, with browser, core, and HTML greeting you at the entrance, all set up and ready to party. Want more guests? Here's where you invite them. Now, if we head back over to the packages, click on Elm/core, where you can see here are the VIPs that are always imported. Why not take a leisurely stroll through package land? The basics module has a lot of math functions, like floor to make floating point values integers, and trigonometry functions like sine, and constants like pi. String, list, and dict are also very important modules. In this video, we'll be using a couple of functions from the string module. If we scroll down, we can see in string there is from int that takes an integer and turns it into a string, and near the top is repeat, which takes an integer and repeats the string after it, like so. Meet add, a straightforward function eager to sum up two integers and return an integer. This binding is actually the same as any other binding. These are all bindings of data to an identifier. So this function is bound to add, where it accepts x, y, and then it returns x plus y. These arrows in the type annotation indicate that this is a function. That's pretty much the only difference. This is how we use the add function. This could also be a literal value like 5. And before this integer value is passed to text, it needs to be converted to a string. So we use the string.fromInt function from the string module, which, as we said before, was imported by default. If string wasn't imported by default, we would have to go import string. It's as if we have already done that. Elm ditches the parentheses in a function call, like you might be more familiar with seeing something like this. Elm ditches those parentheses thanks to something called partial application. I won't overwhelm you with that just yet, but let's write this function so that you can see how you would use some parentheses. So you can go add 5,3. So this is how we would have the add 5,3 execute once. These parentheses make sure this executes. Then the result from add is applied to from int, and then that is applied to text. In Elm, all functions are pure, meaning within a function, the binding in an outer scope cannot be changed because those bindings are immutable. Also, pure functions return the same value given the same input. It's the same every time. So for example, if I wanted to try to change this num value within this add function, it would look like this. Num equals 3, but this actually would just create a new binding. In the ancient libraries of Elm, where functions are spells of creation, we begin our journey. Let me tell you a tale of add, a simple spell that combines two integers into one. Like any good wizard knows, the power of a spell lies in its structure and incantation, or as we call it in Elm, its syntax and arguments. Imagine a magician who hasn't quite mastered his spells yet. He tries to add, but creates ducks instead of numbers. I just wanted to sum 2 and 3, and now it's a party of ducks. This magician reminds us that attention to detail is key in the art of function spells. Copy this code from the description below into the online editor and edit it to get the expected value of 5. Pause the video and give it a try. All we have to do is remove this text, remove this, and now this is returning an integer, and text requires a string, not an integer, so we'll have to convert it to an int and rebuild, and there we have it. Elm is like that cool teacher that doesn't always give homework. So in Elm, you don't always need these type annotations. If Elm is able to deduce them, this will also compile. And that would have come in handy in this example because originally we were returning a string, so it would just deduce the correct value. Higher order functions are like the multitaskers of the Elm programming world, able to take functions as arguments or return them as results. Sometimes even both. We can make a function that takes a function as the argument and applies the next two arguments to that first function. We can then give the add function to that higher order function. Apply is a higher order function that accepts a function as an argument and two values. Then it applies the two values to the given function. This is the add function we saw before, and this is how we use the apply function. If we rebuild this, we see that this works, but if we have these values applied to add, this does not work because this is just a value. The type annotation for higher order functions use parentheses with the type annotation of the given function within the parentheses. Pause the video and think about this for a little while if it's a bit confusing. That's actually quite typical, but as we do use this more and more, it will become more clear. Ever met a spellcaster who uses higher order functions for everything? To open a door, let's use higher order function spells. To make tea, another higher order function spell. Sometimes a simple spell will do, my friend. Not everything is a nail just because you learned to summon the hammer spell. Copy this source code from the description below. Try to get the expected value of 20 instead of the value of 40 that we got. Pause the video now and give it a try. All we have to do is not use this higher order function. We could also have this higher order function just be applied once. So this works, but we could also go change apply twice to just apply it once. Now, I'm just going to cover anonymous functions really quickly in this video, but we'll learn more about them later. If we didn't have this double function, we could actually write that double function in this line and use it. Anonymous functions are also called inline functions for this reason. To write an anonymous function, we start with a backslash, then the arguments. So in this case, we just have x, but if there was multiple arguments, it would be space y, space z, and so on. Then an arrow, and then the result. The result is an expression, in this case x times 2. And if we hit rebuild, we'll see that this rebuilds, and we can even remove these and rebuild again, and it still works. As you can see, inline or anonymous functions are very brief. This can sometimes be detrimental to the readability of the code, so use them wisely. As our magical journey comes to a close, remember, the world of Elm functions is vast and filled with wonder. From the simplest spells to the most complex rituals, Elm empowers us to write code that's both enchanting and reliable. Stay tuned for our next adventure, where we explore Elm's mythical land of lists and loops, loops and lists. Don't forget to subscribe, share, comment, and like, laugh, and code the Elm Programming Show for more programming wizardry and laughter. Until next time, happy coding, and may your functions always perform as expected.